Sir, you are audible, sir. So, good afternoon, Dr. Jitendra Kumar, sir. Uh, is a renowned academician and researcher with a PhD in statistics, a master's in computer science and engineering, specializing in artificial intelligence and machine learning, and is a master of science in statistics. He is a fellow of the Royal Statistical Society UK and currently serves as an associate professor of statistical science at the Department of Mathematics, School of Advanced Science, Vellore Institute of Technology, Vellore, Tamil Nadu, India. With over a 25 years of experience in academia, research, and industry, Dr. Kumar has made a significant contribution to various organizations, including Amity University, where he played a pivotal role in establishing and nurturing the Department of Statistics. His expertise extends to consulting and technical analysis for corporate entities such as Prophecy Technology and DataNet India Private Limited and CESC Private Limited. Dr. Kumar's research interest is span across the diverse domains, including mathematical statistics, computational intelligence, statistical methods and inferences, biomedical statistics, and computer science engineering, with a focus on quality control, artificial intelligence, and machine learning. He is a accomplished another with several publications to the credit and dedicated mentor who has guided numerous students and research scholars. Dr. Kumar actively engaged in scholarly activities such as reviewing articles, designing and curricula, and serving an editorial board of esteemed journals. Passionate about a continuous learning and academic excellence, Dr. Kumar actively participated in conference, workshops, and seminars, contributing as a keynote speaker and facilitator. His commitment to the academia, research, and industry made a very honor to him. I feel Dr. Jitendra Kumar career is marked by his unwavering detection and advancing statistical science in India and forecasting academia growth, making him a revered figure in the field. So once again, I'm thanking for accepting our request to Dr. Jitendra Kumar, sir, and I'm handing over to you, sir. Please continue the session. Thank you to all.
Thank you. Thank you so much. Dilip sir, am I audible?
Yes, sir, you are audible, sir.
All right. So should we start the session?
Yes, sir, yes.
Very good afternoon, one in all present here. At the outset, I extend my gratitude to the Director, Triple IT Bhagalpur, Professor Pradeep Kumar Jain, the Coordinator of Short-Term Course on Machine Learning in Healthcare and Agriculture in a hybrid mode, Dr. Dilip Kumar Chaube, the co-coordinators of the program, Dr. Ujjwal Biswas, Dr. Ravi Shankar Mehta, other worthy members and staffs from the organizing team, STC 2024, a wonderful novel idea, and the most important, all present August participants from ranging from students, research scholar to faculty members. I feel honored to get an opportunity to deliver a session on the topic modeling stationary and non-stationary time series and inferential perspective, a very useful field of statistics that is almost universally used in variety of applications, especially beneficial to machine learning, deep learning, and AI. I will try my best to enrich your existing scholastic pursuits in minimum possible time. At the outset, I can say the time series is very vast, but I'll try to make it very simple. During my presentation, I try to optimize, but my thrust would be on conceptual part because the concept is the basic foundation and bedrocks of all advanced tools, methods, and their applications. Once you're through with that, remaining thing would be done using various forum, a specialized workshop, and other sources of learning. So here, let me allow to share the screen. There is no formal PPT right now, but I take my own notes, which I prepared myself in every talks. So let me give few seconds to share this, and then I'll start my sessions. I'm in the process. Are you able to see this shared material that side? Hello?
Yes, sir. You are visible, sir.
The material is shared material is visible, sir.
Yes, sir. Yes, sir. You are
Okay,
visible and also
Yes, sir.
present.
very nice. So see, my plan here, when we go for time series, these are the key focus. One is the concept and another is tools. When we talk about the tools, we can categorize it into two parts: basic tools and advanced tools. So far as advanced tools is concerned, you can name it like autoregressive model with p parameters, moving average model with p parameters, the combined AR and MA model that is called ARMA model, ARMA model with p parameters, then ARIMA model that means ARMA in integrated form that is called ARIMA model, then SARIMA model, seasonal autoregressive integrated moving average model, the Garch model, and all these are advanced model that is not being understandable before having idea what the basic model. Now the basic model is this many. There are list is long, but few are very common. For example, additive decomposition model, multiplicative decomposition model, deseasonality and seasonal indices, then Cruxel-Wallis non-parametric test of seasonality, single exponential smoothing model, double exponential smoothing model, triple exponential smoothing model. We call him double exponential as Hotling-Winter model also. Then double moving average model, concept and computation of ACF. ACF means auto correlation function. Concept of computation of partially autocorrelation function, how to test if a given data series follow AR1 model or not. So these are the 10, 11 listed basic model. But the question is that, can we start this modeling straightforward? Perhaps it would be injustice to go for that because this requires the basic understanding of the time series and where I need more focus. Then because each of these needs illustration using software and problem solution, then the model would be very much understandable. That could not be possible in 1 hour. But yes, once it be thorough with that, now I start with the basic part. So in the basic part, you can see you can go for exploratory part, components of classical decomposition approach, And of course, these are the objectives that we are going to address, like what is the forecasting technique, analyzing time series, how it requires and why, how you can proceed with amalgamation of intellectual facts of time series data, link time dependent variable with analytical tools as a building blocks, like that. So here we can start with the basics because I can address maybe the UG students also. So here the very first point that make the time series different than other domain. Here in time series, the dependent variable or the output is always a function of time, and that's why we can say that a time series is an ordered sequence of data, especially those data or observation which is a function of time. So here y is a function of time where the t is the input and y is the output. This input is exclusively in terms of time and the output is exclusively through the function that is being used to process this time to generate the output. Now the sequence is very important. Ordering and sequence is very important, and it can be done through two approaches. When you are doing the sequencing using time, or when you are doing the sequencing during using space. When you are using time as a sequencing process, this is basically called temporal basis or temporal time series data. When you are using this using a space, then it is a spatial time series information. And when you are combining these two together, this is called a spatio-temporal data, and that's why the sequencing could be based on this one. In a most of the real time, getting pure temporal and pure spatial is not a very common perspective or common eventuality, and therefore we should focus on a spatio-temporal information. Now, where are the fields where you can find the frequent uses of these concepts? Here I say you almost everywhere, in almost all domain of science, technology, and others. For example, in engineering, in geophysics, in business and economics, in medical studies, in healthcare sector, in meteorology, in quality and industrial statistics, in social sciences, in demography, technical demography, agriculture field, and the list is endless. For example, we observe sound, electric signal, voltage, turbulence, such as the ocean waves, earth noise in an area, daily opening and closing price in a share and stock market, weekly interest rates in the banks and other field, private and public, monthly price indices, quarterly sales of the companies and the government and any organization, uh, early or yearly earning. We record electrocephalogram, very commonly people know it, EEG, in the medical field, electrocardiogram for heart attack patient. This is the preliminary things. Test is very regular. Hourly wind speeds, daily temperature measurement, annual rainfall measurement, monitoring a process according to certain target value, study and records of vital events like annual birth rate, annual death rate, crime rate, marriages, registrations, death registrations, accident rate registrations, annual crop productions, and prices. Again, I say the list is very long. So these are the few examples which I deliberately cited to you to take these concepts of time series, that how frequently and how useful almost every bark of human development is related to and dependent through, and especially in a modeling through these data. Now, when we talk to types, what are the types? Usually, every time series data, whether it is purely spatial, temporal, or combination, can be either continuous or discrete, or you can say even mixed of this. but most commonly we will use the exclusively continuous and discrete. For example, you can say if you consider or apply time series in electro industry or electrical engineering, electronics engineering, where the electrical signals play very vital role and voltage play vital role, fluctuation of these will give you input, then we can use continuous time series modeling. Another way we can see that you are handling the interest rate and banking problem and the financial problem, insurance problem, crime rate kind of problems, crop field study and all, volume of sales in the business. Then you go for a specific time interval, and that requires your discrete concept of time series. So both continuous and discrete concept is very important, and the approach of modeling is different. So we can first have the knowledge before modeling whether the event which we are dealing with is a discrete type or continuous type. Then you can plan your modeling process. Now commonly used time series is of discrete time series as compared to continuous time series. Data in economics, business and other application more frequently we handle discrete. So more focus would be on discrete time series modeling in real-time application. Now the key question is, what is the actual objective of our time series or time series modeling? The answer is very simple. The first one is to develop understanding and description of generating mechanism. How you can develop a mechanism that could lead to time series modeling. And the second point, which is important here, how you do and deal with the forecasting issues in future value. There are three types of forecast in time series: the short term, the medium term, and the long term. When technology is moving so fast, as it happened today, you can see every year there is a unexpected exponential growth in. We can't guess that 5 years before nobody was talking about AI, generative AI, and so many 3G, 4G, 5G. You can see 6G, and that's why technology is very fast today, and a robust kind of movement is happening in a very minimum time span. So in a short term, though in a classical sense we can say 0 to 1 year is a time frame where we can discuss about short term planning and forecasting. When 1 year to 2 year time we are considering, that is sufficiently classically understandable as medium time series forecasting planning. And for a long term, anything's more than 2 year, but of course less than 5 year. Because today if somebody is forecasting after on below 5 year, that is not true forecast. That is lacking the scientific evidence, because a lot of things would happen that we don't know and we don't control. So talking more than 5 year in science and engineering term is really a conjecture, not a forecast. All right. So here we'll talk about intrinsic nature of time series. What is that? The answer is, when we talk about dependent variable, in fact, when the prior of observation, that is the uniqueness of time series, become a base for the posterior information. That means when you are handling the current information, and for that reason previous information is going to play a valuable role, you can say that this is intrinsic dependency concept in a time series, and that is highly correlated. So previous past information provide the basis of the current information, and current information provide the basis of future information in a highly correlated manner. Then such a analysis can only and exclusively be done using time series modeling. And here is the time series is unparalleled compared to other mathematical modeling, deterministic deterministic nature and other nature. So here we can call it as definition of time series, that when you are handling a point of time t1, t2, t3 and tn, and when you are having the event corresponding x1 at t1, x2 at t2 and xn at tn, then we can go to develop a model that will be xt as a function of time t, and then it become a time series workable function. So here some of the utility. What are the utilities of this function and time series modeling? Here few I have mentioned. I discard many one, but few is very common and very useful. Number one is utility one, analysis of past behavior of a variable require time series modeling. The number two utility is forecasting and planning of any events for good governance is very important. Even in today, every part of the world, without forecasting and planning, you cannot handle. So analysis of past behavior provide the true basics of future and current plan, and that's why forecasting and planning is one important. For example, analysis of time series relating to income, or you can say wages in a labor and force industry, or you can say the production plan. This would be the basis for forecasting the future income or the future wages pattern or the future production pattern of a company. This helps in making the future plans of actions, future projections, future plans of actions based on the projections, and setting the target. This can easily be done in a scientific manner using time series modeling. When we talk about the third utility, which is very common for time series, it enables us in evaluation of current performance, current achievement for any company. For example, one, so progress of our 5 years plans can be just through annual growth rate in GDP and GNP. Example 2, the evolution of our policy of controlling inflation and the price rise is done by the a study of various price indices available in a time series fashion. So these are the utilities. The last one, which the fourth one, after that I discard the other utility of micro important. Here the time series enable us to making a comparative study. That is again very important, because you can't go for decision making process without going for comparative study. You have to do the comparison, you have to develop a relation, then you develop a model, and then only you can have decision making. So comparative study play very important role, and here the time series modeling is very important, because one time period performance to another time period performance could give you a viable and reliable idea. Now we will talk about, after discussing the four utility, I move to components of time series, because you cannot progress to or jump to modeling without having idea of components of a time series. There are four basic components of a time series that play very important role. A time series is the result of combined effect of these different categories, or you can say different categories of forces that brings changes in value of the output variable under the study. That means xt is basically decided by the force. One force is called trend, or we can call it long-term movement. The another driving force is seasonal variation, we call it S. The cyclic variation presented by C, and irregular variation that is difficult to control, unforeseen variation, and that is I, but its impact is very, very important. Or you can say it random variable. So that's why there are four components in a time series modeling. Whether you do the basic modeling or you go to advanced modeling, you have to deal with these four components either exclusively or in combination or in an implicit manner. When we talk about a statistical model and forecasting, here there are several different statistical time series model used to analyze and solve a stationary and non-stationary time series. I will discuss a stationary and non-stationary time series and its meaning just after that. The basic term that is important here is called in-block method. So here the key concept involved is the estimated parameters are invariant with respect to time. If estimated parameters does not depend, right, or does not be affected over a period of time, then it is called invariant in nature. Such a model is known as time invariant parametric model. So time invariant model in a parametric model play indispensable role in a time series forecasting and modeling process. So here you can talk about decomposition, you can talk about exponential smoothing modeling, because if you have to smoothen the data first. Under the exponential there are three categories: the single exponential smoothing, the double exponential smoothing, that also we called the Holt trend model, and the triple exponential smoothing. Here you can understood that when in a given time series data there is trend, no trend, and also there is no seasonal effect, right? Then we can prefer this one, ACS. That is the first case. The second case is, yes, there is a trend, but there is no seasonal pattern or seasonal forces. Then we'll go for second option, that is called Holt trend model or double exponential model. When you meet the third case, that is, yes, trend is there also and seasonal impact is also there, then we prescribe to the third one, that is called triple exponential model, or we call it Holt's seasonal model. So this is the guideline you have to, before going to modeling, the analyst must think of the data and their components and must become insure before doing the any or proceeding for modeling process. Now we'll come to the next thing, that what are the commonly used software that you can use in handling the time series modeling. The very, of course, most powerful one and very common is MS Excel. You can do it MS Solver. You can use it Minitab. You can use it R as open forum. You can go for even SPSS for social packaging. You can go for SAS, which is the most powerful software in the world. You can go for a Stata. You can go for a StatCraft. You can go for Python, and the list is pretty long, right? I have deliberately, but these are very common, right? Here, the general category of time series modeling, the first one is additive one. You can see here all four models, that means all four components in this model, additive model, is having additive effect. So trend is having additive effect with season, season is having additive effect with cycle, cycle is having additive effect with irregular component, and of course all these components is controllable. But one component that is not controllable, that is called error term or uncontrolled error or random error, without which you cannot develop a model. So this component is basically the head and brain of the model. So when we talk about first decomposition model, it is called additive model. When we talk about the second, that is called multiplicative decomposition model. Here again these four components are there, but not through the operator is changed here. In place of operator plus, you are using multiplier, and that is why the effect is multiplicative in nature. You can assume that additive effect is linear in nature, but when we talk about multiplicative effect, it is non-linear in nature, or you can say exponential in nature of, right? So multiplicative model is always very powerful than additive model. Of course, here also the random component. But in a real time, very few or rare events are purely additive and purely multiplicative. Basically, we have to deal with mixed model where part of these components are additive in way, or part of them are multiplicative in nature. For example, if you talk T plus S, trend and season are additively related, whereas the cyclic and irregular component are having relation with multiplier effect, and this multiplier effect is having additive relation with separately each on trend and season. So T plus S plus C star I is example of mixed model. Similarly, T star S plus C plus I is another example. Any possible permutation and combination is an example of mixed model. Now I am taking you that how do you proceed before modeling. You must know, because modeling is done for forecasting, but what are the steps of forecasting, what are the classification and grouping of forecasting, that is also very important. We can make three groups for point of view our application and study. The first group of forecasting is basically, we call it subjective procedure of doing a forecast. It is purely based on experience. It is purely based on judgmental approach in nature, and there is lot of subjectivity and debate here. Your intuition or your experience based intuition intelligence is very important here. So that is, you cannot say it non-scientific, but of course here a lot of experience based and field based experience play very important role. So I have given it here, practical experience play very important role in subjective procedure. Now the second one, that is the scientific approach, and this is called univariate procedure, or you can say it univariate time series modeling, right? And then it comes multivariate approach, right? So each character of univariate is extended to multivariate, and then we call it a procedure that is called multivariate time series modeling, right? So first you have to very good in univariate approach, then extend all these concept to the multivariate approach, and then you can use sometimes univariate and majority of the time multivariate procedure of doing the modeling in that one. The contribution of Box and Jensen are very important. He a great statistician, you can say a great mathematician, who virtually or literally revolutionized the field of time series, and that's why called the modern time series is having 70% of applications from Box and Jenkins approach directly. So there are three approaches here. You can say three steps of forecasting procedure using Box Jenkins approach. That is, one is called model identification. How do you identify the model? That's very important. Then you call the estimation parameter, estimation of parameters, because in a modeling you do either estimation of the parameters or you do testing of estimated values. When you do the testing, again you can do for advanced testing and non-advanced testing. There are, when we discuss about hypothesis testing, it is a Neyman approach, it is a continuous approach, sequential approach, SPRT approach, and the field is that another topic that we cannot discuss right now. So estimation and testing plays very important role. And the third one in a Jenkins approach is diagnostic checking, diagnostic measures. That means how do you ensure that assumptions made about the model is valid or not? How do you diagnose it? For example, when you handle time series regression modeling, you have to check the various assumptions like does the multicolority are there? Does the auto regressive assumptions are there? That the assumption of linearity and normalities are there? All those you have to check out. Does the assumption of constant variance and homoscedasticity are there or not? So diagnostic checking is very important. And once you do these all three steps together, that completes your modeling process. So here, just for example, to insight idea in you, I say, if we observe that given time series having, as I explained earlier, no trend, no seasonal effect, go for a single exponential smoothing model. There is trend and no seasonal impact, go for double exponential. Just previous page I explained it. And if there is both trend as well as seasonal impact, then for a triple exponential or Holt seasonal model approach is there. Now here I given you a small example. For example, if the time series is seasonal in nature, that means seasonal component is very important force in deciding the time series trend and time series weightage. Then in that case, which model is suitable? Of course, there, as I say, advanced model SARIMA is recommended. So here, seasonal auto-regressive integrated moving average, in short we call SARIMA, is recommended to you. Like that, before jumping to time series modeling, you should be very clear in your concept that what you are doing, which model you are going to use, and how you can use, what are the required data set, and once you have this data set, that is going to be a plausible solution or not. So the modeling is not just a process, a formula, and just a technique. Rather, it involves a comprehensive integrated approach and understanding to do the modeling. And that's why modeling is a teamwork rather than individual. Individual scientists cannot do the modeling. Modeling requires expertise of few people in that related domain. For example, if you are a scientist, want to do a modeling for healthcare sector, do you think only a statistician should do that? So a statistician supported by a good mathematical knowledge means pure mathematics people, then a team of healthcare related healthcare sector expert people, maybe from biomedical scientists or maybe from microbiology and maybe from genetic engineering, and those team together sit and then think and plan for modeling process. So a data scientist or a statistical job or whatever the computational intelligence application cannot be done individually, and that is a very important that's why the role of multidisciplinary expertise and interaction and communication in a technical way is very important play to handle a project. No matter what kind of project you are handling to, your teamwork is required. So here I can see that there are some another approach also. For example, if you want to go for Sarima model, can we do have some another approach? Yes. In place of Sarima approach, we can go to Bayesian approach. So Bayesian forecasting analysis is another way out. So doing the things differently is the more exciting thing. And after that, you can compare which way is most useful, which way is more plausible, more authentic, and more time and space gain you can do it. Kalman filter approach you can apply also, right? So what is the Kalman filter approach? As I said that this advanced time series that cannot be covered here. Linear filter approach, the non-linear filtering approach. Oh, there are so many things are there. So both of these based on recursion and iteration process. Again, you can say recursion and iteration are different. They cannot be same, but it appears to be same. We can focus on iterative approach. Sometimes a problem given can be solved using recursion when a function call itself, that is recursion, but iteration cannot, every iteration problem cannot be solved by recursion and vice versa. So we have to think on that very micro level, and then you go to your actual fitting of time series modeling. Now we'll talk about some of the do's and don'ts related to performance of a time series modeling. How do you make ensure of it? So there are some quality forecasting dependent factors and criteria. What are those criteria? These criteria, the very first one is objectivity. The second one is validity. The third one is reliability. The fourth is accuracy. The fifth is confidence and sensitivity. As a undergraduate student and most of the research scholar which I am handling to in even Belor campus and many more other branches people I come across during my 25 year of expertise, people are confused. They don't know the difference between validity and reliability. They actually don't understand or maybe confused in accuracy and sensitivity, accuracy versus precision. People even oftenly confuse between standard deviation and standard error. Many times I ask the master student, master of data science student, MTech student, what is the difference between standard deviation and standard error? I surprised they not answer it clearly, or even they answer it partially correctly and partially incorrectly. So the audience, I appeal to you all, whenever you handle a modeling process, you must be very particular about all these terms before going to in a practical way. So what is the objectivity means? The objectivity means there is lack of subjectivity. You cannot debate. You have to agree on a point. There are 10 scientists. You cannot take 10 different directions. You have to converge to this point. That is called objectivity. And without objectivity, the decision process cannot be. So that way, in a science of decision making, the role of scientific computations, especially the stochastic approach, the modeling approach, the simulation approach, play very important role, right? And that's why the era, the modern era, which we are going to turn from the robust era, we can say, and the quantum computing time in future also, is objectivity driven. Now, validity, another term which is very important. So, what do you mean by validity? A forecast is valid if forecast series and the original time series is being examined to highly correlated. So, if there is no correlation or partial correlation between the actual one and forecasted one, we can say there is lack of validity. So, having a complete understanding of correlation, again, I would like to talk here. When we'll talk about correlation, is most of the people just talk about Karl Pearson correlation and linear correlation. No, not at all. There are non-linear correlation, and that could be measured by correlation ratio, eta. When we talk about UG, PG, and even research scholar, they don't know. Mostly they talk about R is equal to correlation coefficient. They maximum talk about rank correlation rho or correlation correlation R varying between -1 to +1. We ask them what happened, how do you measure nonlinear correlation? Because a functional relation in mathematics, if and y, if you say that the functional relation, who say that x and y are only linearly related? If x and y are exponentially related, parabolically related, elliptically related, or there are thousands of functions that is nonlinear, how do you measure the correlation between them? Have you thought on that? Go for correlation ratio and eta. Now we'll talk to reliability, because all these topics needs a separate discussion. What about reliability in general? Reliability relates to consistency, and the more consistent the results, the more reliable the forecast is. And consistency is again very vital. So reliability means consistency in performance. When you or your tool or a method or software perform again under different circumstances to the same level of precision, we can declare it reliable. So reliability is directly related to consistency, and validity is different concept. More reliable means more valid. You can't claim, but yes, validity lead to reliability. That is true. So again, validity relate to reliability. You cannot say every reliable is valid also. No. Sometimes you might feel that a reliable situation cannot be a valid situation too. So reliability more related to consistencies than related to validity. Now we'll talk about accuracy. Again, is a different concept, but somehow related. So it's a homologous in concept. Similar seems to be in pronunciation, in meaning, but actually in implementation, you have to be very thin into introspections of this one. So accuracy is closely related to validity. It is not possible to have an accurate forecast that is not valid, but it is possible to have the valid forecast but not accurate. So this line is very important. Accuracy ensures validity, but validity may or may not ensure accuracy. So all these measurement and concept needed before going to time series modeling. Now I am talking about another element, that is confidence. When you are handling a time series forecasting as a model builder or a modeler, how do you go for confidence measurement? So confidence tells us in true probability measure. So confidence is a probability measure. It's not. It's a measurable in terms of probability. So confidence tells us with what probability we should accept the result of the forecast. If you are not measuring that probability, that's why you need to find out the confidence interval 100 at 100%, alpha is equal to 5%, alpha is equal to 2% level of significance and all. So it is a probability measure that give you minimum and maximum limit within which the estimated value is likely to lie. And then we'll talk about sensitivity. What is the sensitivity? It is more related to method than the results. The rule is more scattered the result. That means randomness is more, right? A method are, if we have used different types of data, the more sensitive. If you find a pattern rather than a randomness, suppose the data is moving in a divergent manner, or is moving like a sinusoidal way, or it's going like a certain function like tan function like this, right? Then it is a pattern. So pattern is means insensitivity. No pattern, purely random. When you plot error versus time, error versus any factor, you get random error, then you can say it is more sensitive forecast. Now conclusion for this element. To conclude from criteria 1 to criteria 6, we may say that we should prefer to implement a sensitive and reliable method which is producing valid and accurate forecast placed within an acceptable narrow or a smaller confidence length. You imagine here, when you are having a model 1, suppose you apply model 1, right, on a particular specific situation, you construct the confidence interval and generate the confidence length, and the confidence length is x1. Let's take for example, now you applying model 2 to the same situation with different set of variable, and you generate another confidence level that is called confidence level 2, or it is confidence length is x2. Now suppose you got x1 is less than x2. That means confidence length of the first modeling process is smaller than confidence length of the second modeling process. Whichever is better? Whichever of these two modeling is better? So shall we go for model 1 or shall we go for model 2? The answer is very simple. You should prefer the model result in the smallest confidence length. So we prefer model 1 because x1 confidence length generated through model 1 is smaller than the confidence length is generated through model 2, and therefore model 1 is preferred over model 2. So these are the way as a investigator, as a scientific investigator, you must go for this inferential, descriptive, and exploratory approach in developing model process and evaluating your modeling. Now I'm talking about a few minutes on forecast error, and everyone, I guess, in this audience is very clear about definition of error. Error is basically the difference between the actual one. If xt is actual and ft is forecasted or estimated, then what is the gap? This gap is called error, and that's why at is equal to xt minus ft. Ft means forecasted or estimated value, xt means actual value. Now there are situations. Situation 1, error et should be a random variable. That is first very important thing. If generated error is having a pattern, there is something wrong. We can't expect a good result from such kind of thing. So error generated must follow random behavior and random attributes. When you plot error versus time, error generated through a model, and if it is random nature, it is well and good. If it is having a pattern, there is some doubt about it. You need diagnostic, you need investigation and examination. Now the second thing, variance. Variance of error should be minimum as possible as. You can say in statistical sciences that minimum variance and biased estimator is the foremost desirable condition in any estimation process, MBUE. And for that, when you go to statistical inference, you see the Kramer-Rao inequality and other criteria that ensures you that estimated variance is whether a minimum variance and biased estimator or not. Even you don't go for Kramer-Rao inequality and all, then you have to go for the Gauss-Markov theorem, right? Of both cases. One is simple case where the variance of the xi must be constant variance case. And if you go to non-constant variance way, that is called when the variance of the xi is a not equal to sigma I square, rather than It is a variance covariance matrix F this sigma I, variance covariance matrix. Then it is called Gauss-Markov theorem general case. Here, what is the difference? When you apply the Gauss-Markov theorem first case, constant variance case, it will lead to the OLE, ordinary least square estimator. When you apply the Gauss-Markov theorem and for second case, general case, it is called GLS approach, generalized least square variance approach, or GLS. For example, when you go to simple multiple linear regression and multivariate linear regression, OLS approach will do a good job. But when you apply the same estimation process on logistic modeling, the OLS will not deliver the blue, best linear unbiased estimator, and MBUE, minimum variance unbiased estimator. Then you have to go for GLS approach. Under the GLS, even you not satisfied, then you have to go the another numerical search method to estimate the parameter involved in model like Gumper's model, Pareto model. You cannot apply the OLS model in Pareto or GLS model in Pareto. So please understand this modeling intricacy, and then you can do the modeling process. Now I'll talk about some of the error. For example, how do you go for minimum error? Minimum error is very simple approach. You can compute the error and then you can just take the average value of this error. So sum of all error divided by n, it is called mean error, right? And then if mean error is greater than 0, this show a systematically positive biased kind of forecast. If mean error is less than 0, this will shows the systematically negatively biased forecast. When a mean error is 0, it shows ideal cases. That means the forecast is evenly distributed and even a small fluctuation are there, it is unbiased forecast. So this is a good criteria. That means mean error play important role in giving you a kind of idea whether systematically positively biased elements are present in your forecast or systematically negatively biased elements are present in your forecast, or your forecast is going with simple fluctuation in a random fashion. That is case, ideal case. We prefer the third one. Now, how do you measure the mean absolute error? No need to discuss it because most of the tools and most of the UG level teaching, they trained MAD method, mean absolute deviation method. This is a small formula. I can share this my notes to Professor Dilip Kumar Chaube to share with the audience. Maybe they can send you through the Google Drive and all. So here, mean absolute error we can compute very sum total of all error, then neglect the plus and minus, and then you take the modulus value. Sum of all this modulus value divided by n will give you mean absolute. But it is insensitive in nature, not good. Any insensitive tool cannot be treated as a good measures or good tool in a statistical science, and therefore we cannot rely on MAE, right? So we could discard it. Generally, it is biased in nature, insensible and biased both, and therefore we can discard this approach. So we'll move to second one, that is called relatively better than this one. So we prefer MPE over mean absolute error approach, and this MPE is mean percentage error. Here you can compute, you can see here percentage error divided by xi into 100, then you take this summation and divide it by total number of errors, and then it is called. So this is more sensitive measure, and we prefer MPE method or MPE percentage method over the previous one. But that is why I have written the third one is MAPE method, mean absolute percentage error method. We multiply this the same formula by 100 and we got it. But again I say the MAC is better, or root MAC is better. Root mean is square error, that I will discuss later on. So here I'm moving to another phase because time is limited one. So here now I will so I have given you this basic discussion. What is the time series? The time series can be of two types. One is a cross-sectional, another is longitudinal. Cross-sectional means when data is collected at same point of time. Longitudinal means data collected at different point of time. Let's take example of cross-sectional data. For example, daily measurement of time in the morning, the minimum temperature, And after post noon, that means between 2 o'clock to 3 p.m., the highest temperature of a day. Every day we are measuring by major meteorological station. That is an example of cross-sectional data. When you take the gold price at 10 a.m. opening price and then closing price 5 p.m. and you, this time the entire country is having a common gold price throughout by the and another the share prices in declared by Mumbai Stock Exchange and other stock exchanges at 10 a.m. in the morning and 5 p.m. That's the same point of time is example of cross-sectional data. But when we talk about daily business, yearly business, monthly business, quarterly business, hourly business, then it is called longitudinal time series data. And then I have gone through those discussions of the basic. Now I hope the audience is very clear how we can evolving through the time series. So we have started from a crunch and then we are evolving through little bit more and then later on call the stationary and time series modeling process. So forecast error I have talked to, and then this mean error concept I have talked to, elements of biasness, reliability, validity, this discussion I have done, the components of time series I have done, and now I am talking about this concept. What is the auto covariance and auto correlation concept? You see that in a time series, the previous time and related event play important role for the current time and important related event. So that's why the current event is very largely dependent in function of time to the previous event, and that's why the concept of lag is there. Concept of auto correlation. Auto means automatically, self correlated. That is the term autocorrelation. So the statistical measures that indicate how a time series is related to itself over time, it is called auto correlation and auto variance. Now, how to compute it? For computing the auto correlation, you can talk about the correlogram. That is another popular graph. You have heard about a scatter diagram. So, for example, the auto correlation of lag 1. So, when you talk about lag 1, lag here 1, lag 2, lag 3, and then we'll take the correlation value rho here, rho I at different lag. For example, correlation at lag 1 is rho 1, correlation at lag 2 is rho 2, and when you make a plot, this plot is called correlogram. This is not called a scatter diagram. When you talk about a scatter diagram, x versus y, when you take the correlation between x and y, then it is called a scatter diagram. When we'll talk about correlation this side and time lag this side, and this diagram is called correlogram. Correlogram is very, very important in handling the harmonogram analysis. That means when you are handling a time series where the predominant factor is neither a trend, not a cycle, not a season, but a regular component, then correlogram is very, very important, and all mathematical treatment will be based on harmonogram analysis, where the role of sine function, cos function, and time function, tangent function will play very important role. Now I'll go to auto covariance. What is auto covariance? The covariance ZT suppose we denote it, and the lag value of ZT, T plus K, separated by lag K, is called the auto covariance. And the formula you can see like it's a normal covariance. That means denoted by gamma K. It is covariance between XT and XT plus K. K is the time lag. And that's why you can see the usual statistical formula, expected value of XT minus mu and the XT plus K minus mu. This value, if you compute, you got the gamma K, and that is called covariance. E means estimated or expected value. Mu is the population parameter. That means the true mean or stochastic process, and therefore when you compute the rho K, that is called autocorrelation function at lag K. It is estimated value, that is the covariance, divided by a square root of variance. Basically, this is the structure of simple correlation formula. In the same in autocorrelation also, we can apply the same formula, but it is in respect of lag time. Time lag play very important role. So when you solve this, E of xt minus mu into xt plus k minus mu in numerator, and when we divide the variance of xt and variance of xt plus k, and then you take a square root of these two variance. This is variance 1 and this is variance 2. and then you take the square root of the product of these two variances. This become your denominator. When you take this numerator and denominator ratio, it will give you rho k. I will give you the formula, and I can show you on software like in R and all. It's a small function to calculate. When you talk ACF function in Python or in R, that command will directly lead to this. But my focus would be on, if time permit me, I can show you right now the how we can compute each of them on a given data set one by one. But that time is not feasible at here. That's why I given thrust on this portion, because when I illustrate on Excel sheet or MS Solver or even in Power BI also, that will give you a very good understanding, because those Python and other advanced software, they are using the command, they are using the function, library function. They don't give focus on how basic computation is being done. For UG student and for researcher scholar, it is very important to hit the crux, the basic things, how you learn each computation, then only you go for automation part, right? That definitely have advantage of solving the time and saving the time and giving you accuracy in calculation. But basic foundation and calculation is first. So here rho k can be computed using this formula, and also you can say that rho k is ratio of gamma k, that is covariance, upon gamma naught, and rho k value is 1 for beginning. Now you can say that autocorrelation is dimensionless quantity because it is a ratio, and it is independent of a scale of measurement. So unit does not play much role here, right? And then this will be unit free, and that's why it is useful also in that way. This is one of the merit. So autocovariance can be computed very easily. Now I have a single point that I would like to foresee here. You can compute the covariance between x plus y into z, and then this is a basic property of covariance. It would be covariance between x and j plus covariance between y and j. No need to discuss all because these are elementary first year UG program teaching, and that's why covariance between ax comma j, it become covariance a of covariance between x, and these are the basic property that is needed, and that's why I discussed. Now I'll talk about a standard error of the sample autocorrelation. How do you do that? Here you need to find out some base. So you have to develop the hypothesis. Let's say null hypothesis, rho k is equal to 0 and rho k is not equal to 0. Again, here I would like to discuss you that what is the null hypothesis. I think most of the students know that, and most of the worthy audience know that, but many are confused also. Null hypothesis is a specific statement or a stochastic statement, or you can say probabilistic statement, or in another language you can say statistical statement. Every statement cannot become null hypothesis. It's not a generic statement. So a stochastic statement, probabilistic statement, a statistical statement regarding population parameter, that word is very important, is null hypothesis. If you talk about h naught, let's say h naught x bar x is equal to 5. Is it correct null hypothesis? No. Why? Because x bar is not a parameter. But when we talk h naught mu is equal to 5, then it is correct null hypothesis. Why? Because mu is a parameter. So my point is that null hypothesis never involve a statistic. It involves parameter only. So any statement, a stochastic statement or a probabilistic statement based on the parameter will be the part of null. Second point is it is two-tailed. Why? Because here the rho k can take greater than 0, positive autocorrelation, or possibility rho k may take less than 0, negative autocorrelation. Right? So again here it is called two-tailed. A null hypothesis could lead a alternative hypothesis, that is counter of null hypothesis, maybe of one tail or two tail. The third concept related to null hypothesis for the audience is this is an example of rho k is equal to 0. That means you see that rho k is specifically defined. When parameters are specifically defined, then it is called simple hypothesis. But when suppose in place of rho k is equal to 0, it would be written rho k greater than 0. It means that rho k could take any value above 0. Maybe it is 0.1, 0.2 or 0.9. There is infinite, a large number of possibilities. That means it is not specified particularly. In that case, It is called composite null hypothesis. So the audience, you should be very clear. A null hypothesis should be of two types. It is simple and composite, and therefore we can develop a hypothesis: simple versus simple, simple versus composite, composite versus composite, composite versus simple. So this is again very important discussion for clearing the concept for UG students present here. Maybe research scholar also find it useful, and of course faculty members expected to know this. Now I'm talking about the what is the second step. The second step is find out this statistic rho k upon standard error of rho k, right? Once you calculate this standard error for rho k, this is called AC rho k and this is called rho k, so it is T statistic, right? Then you can compute the variance of rho k. How do you compute the variance of rho k? The variance of autocorrelation estimated value will be 1 by n into 1 plus 2 sigma nu is equal to 1 to q rho nu square. But in most of the cases when this is 0, you can say that for a large sample or for a cases when rho v square summation would be 0, then it simply become 1 by n, right? That means in most of the asymptotic cases, the variance of autocorrelative autoregression estimated value would be approximated to 1 by n. For mathematical simplicity, this approach requires to be very important, and that's why most of the non-parametric tests done for the time series modeling consider the ACF variance as 1 by n, where n is the sample size. So this reduces a lot of time in your computations, right? Other than when you compare this formula, it is more time consuming. But yes, we have to negotiate between approximation and some sacrifices in efficiency at this stage. Now, how do you measure the standard deviation? Of course, you can use the basic rule. The positive square root value of variance would be there, and that's why you take the square root of this variance, and then this standard deviation of rho k can be calculated here. If rho k will be 0, then standard deviation of this would be a square root of 1 by root n, and this is a very important aspect in finding out the inferential criteria, and we will check it very easily to find out a standard deviation. If we get a standard deviation upon 1 by root n, we can easily relate whether the autoregressive measures would going to be in right direction or some kind of anomalous present there. Now I'm talking about autocorrelation and autocovariance. Here you can see the autocovariance provides the basis for autocorrelation. So autocovariance matrix is associated with a stationary process for observation. Let's talk about x1, x2, xn are the finite observations made out of the n successive time event t1, t2 and tn, and it is denoted by a matrix form. Let's consider the symmetric matrix here with a constant variance. This is the diagonal elements. All diagonal elements you can see here gamma naught, that means constant variance, and then remaining are the gamma 1 covariance system. So off diagonal are covariances and the diagonal elements are the variances, and this will be the autocovariance matrix. Now a covariance matrix you can denote it by this symbol or using this symbol of the above form, which is symmetric with constant elements on any diagonal, will be called the autocovariance matrix. And this is the basic structure of autocovariance matrix, right? And then this will help you in numerical solution. And finally, I am leading to evolving to the sigma n, right? And that could be gamma naught into this matrix. This matrix means it's called PN matrix. PN matrix consists of autoregressive coefficient. It is 1, 1, 1 on the diagonal matrix, and off diagonal matrix would be the autocorrelative function rho 1, rho 2, rho n minus 1, and that is the basis to calculate the sigma n. So sigma n is equal to gamma naught into P of n, where P of n is known as the autocorrelation matrix. So for finding out the ACF, we have to find out the Pn first. Here the process of stationarity, what for a stationary time series data of the autocovariance and autocorrelation matrix associated with the process are positive definite matrix. Let's consider the linear combination. Again, you can see that you can take any linear combination. So let's consider it is called variate. So every linear combination that is expressed as sum of Li into xt minus I plus 1, where I could be any value 1 to n, and I can demonstrate it using data set, then it become very easy. So the building block of time series modeling is called, especially the multivariate time series modeling, is the variate. Without finding out the variate, if you work with the multivariate time series modeling, you cannot get the achieve and cannot get conclusive result. So what is the variance of the linear, what is the variance of this variate? Variate means linear combination. This would be double summation Li Lj gamma j minus 1. So now I'm talking about brief of, I'm leaving this mathematical treatment here. So stationary versus non-stationary behavior of time series. How do you achieve this stationarity? See, first, when a time series is moving with constant mean and constant variance, then it is called a stationary time series. If the time series is evolving through the time with different mean and non-constant variance, then it is called non-stationary time series. So a stationary and non-stationary time series play very important role in modeling process, and that's why before doing the modeling you have to be clear whether your time series at hand which you are dealing with is a stationary or it is non-stationary. Here there is a method of the finite difference, or you can say backward shift operator, that could convert a non-stationary to a stationary time series. You can define it like bxt, a simple mathematics is xt minus 1, b square xt, xt minus 2, and similarly b raised to power j xt would be xt minus j, and that is called the difference operator delta 1 minus b. There is a relationship between the backward shift and 1 minus b. It is delta is equal to 1 minus b. Delta of xt could be 1 minus b into xt. When you solve this, you can find this common relation. Delta of power d may be delta square xt, delta q xt. You can find out 1 minus b, d value 3. For example, delta of second order xt, you have to find out the time lag of 2, order 2, it would be 1 minus b power 2, where b is the backward shift, xt, and then you can solve. Xt is equal to data, maybe 2, 3, 4, such things will be given. Then you have to take the difference, delta xt, delta xt will be 2 minus 3, 3 minus 1, like that. Then second order, 2 minus 1, then 3 minus next value would be the next value, like that. So successive difference you have to take it. So if you apply the finite difference approach, you can convert any non-stationary time series to a stationary time series. It depends upon data set that whether you go to the first order differential differences or second order. In most of the cases, we will get the practical utility and we restrict ourselves to second order. Now, seasonal difference operator is also very important. Here we can use the suffix season s to differentiate from delta. It is called seasonal difference. Again, seasonal difference is defined as delta s is equal to 1 minus b raised to power s. So seasonal difference is required for a time series where the impact of seasons are very high. You can see in India, the most of the business sales rises in third quarter. That is called the festive season, Deepavali, Dashara, and many festival, Pongal and all. It happened between October to January, and therefore the seasonal impact will be very high. All business during third quarter has multiplied manyfold, and that's why you can see third quarter is very important in Indian business, or the like that other countries also. So here there is a relationship by t is equal to delta s xt, and finally we can see a formula that we can use for computation purposes. By t is equal to xt minus xt minus s. Seasonal component will be there, then only we can go to this approach, right? So now from here onward, because time not permit, we are now in a position to start the modeling, and that's why I can say the first page means here we can now proceed to first page from here onward only. So here, since I have given this all basic concept at this stage, now we are in a position, you can see here, that we can move to these tools. Without discussions of this concept, we cannot start even any of this modeling process. So now the actual time series modeling is start, and the first model I suggest is additive one, second multiplicative one, deseasonality, crucial voltage, single exponential, double exponential, triple exponential, double moving, and then concept of computation of ACF, then PSEF, then fitting of AR model, then you can go to this modeling, without which is useless. Then you can proceed with advanced modeling, that means ARP, MAP, AREMA, ARIMA, SHARIMA, GARCH, and other advanced modeling. So here it is showing 347, and today's valedictory session, as per instruction I have received. So I would like to stop at this point. For the audience, I am open to have a question session. Anybody can ask any term and concept which I have discussed you right now to make it further creative. So let me stop at this point. Thank you so much from my side. At this stage, I am open to the query session now. Can you go for the queries? Any audience can ask any questions related to the discussion held so far.
Hello, good afternoon to all participants. If you any question, please ask to sir now.
Yes, we can go through.
Dear participants, if you have any question to you, please ask now. There any question to say?
In this material, I am going to share to the WhatsApp group to Professor Dilip Kumar Chaube for the beneficiary, especially the UG student and research scholar, because I hope this material is definitely going to give you a complete basics of time series modeling, and then you can do the advanced modeling as I discussed and explained here. Maybe if time permit and some good opportunities I got, then I can have a workshop there to some extent in future time.
Thank you very much, sir, for your permissions. It will be very good for the participants, I feel, and because this material is a very informative materials. So now I'm going to conclude this session. Thank you, Professor Dr. Jitendra Kumar from the Department of Mathematics, SAS VIT Vellore, Tamil Nadu, India, for your enlightening presentation during the short-term course. Your discussion focused on the time series analysis within the realm of the machine learning and AI, providing a critical insight into the effective application for monitoring and predicting various industry trends, notably the agricultural applications. Your presentation covered the broad utility of the time series analysis, emphasizing its relevance across diverse sectors such as the finance, weather forecasting, and energy management. This cross-disciplinary approach underlying the techniques very well and versatile and essential role in data-driven decision-making system and research. Moreover, you developed into EA challenges associated with the forecasting errors, offering details explanation on how to measure and minimize these errors to improve the accuracy and reliability of the predictive models. You also stress the importance of understanding bias and variance, fundamental concept and theoretical concept that must be balanced to refine the model performance and ensure a robust, reliable predictions. Your enlightening presentation are not only informative but also immensely practical, empowering participants with the knowledge to apply these theoretical concepts, advanced analytical tools in their respective fields. The depth of your expertise and your ability to convey a complex concept in an accessible manner greatly enriched our learning experience, and we are grateful to you have with you in the short-term course, and it really impact. We hope that it really impact in this short-term course. Your lecture has had over understanding and advanced machine learning technique. So I thank you once again, sir, for truly valuable and theoretical mathematical concept on mathematics and artificial intelligence concept. It will very truly important concept what you discussed. Thank you once again to sir and accepting our request, and thanks a lot to sir.
Thank you so much, sir. Thank you, all people, especially the audience who has given focused attention. I definitely feel proud to get an opportunity. It's all because of the Triple IT Bhagalpur Nobel Profession for towards a service towards the nation. I look forward a further success. Already, the session is fifth day. As per my knowledge, and some of the audience approached me from my organization also. They are really feel very glad about all sessions so far. Let's look forward the valedictory session. Thank you so much.
Thank you, sir. Thanks a lot to sir. Thank you, sir. Thank you, sir. So, in absence of our respected directors here, I'm like to take permission from our campus coordinator, Dr. Dheeraj Kumar Shina, to start our valedictory session. So, thank you, sir. There is a saying, all is well when ends well. So, first of all, thanks to all dignitaries in the dais, and we are fortunate to have Dr. Dheeraj Kumar Shina, campus coordinator, and the coordinator, Dr. Dilip Kumar Chaubey, and our HOD, Dr. Tejaswini M, and the co-coordinator, Dr. Ravi Shankar Mayata sir. So I want to welcome you all for the valedictory session for the short-term course on machine learning in healthcare and agriculture. I'm also welcoming all the participants, co-coordinators, coordinators, my dear colleagues, and the committee members, expert lecturers, and the head from all the participants, all the departments, and very good afternoon to all of you. Now, I'm requesting our coordinator, Dr. Dilip Kumar Chobe, to welcome our campus coordinator, Dr. Dheeraj Kumar Shina, with a bouquet. Thank you, sir. Next, I would request the co-coordinator, Dr. Ravi Shankar Mehta, to welcome respected HOD Madam, Dr. Tejaswini M, from the Department of Computer Science and Engineering. Thank you so much, sir. Now, next, I would request the coordinator, Dr. Dilip Kumar Chobe, to deliver the valedictory speech about the 5-day short-term course.
Hello, respected Director Sir, Professor Pradeep Kumar Jain, Campus Coordinator, co-coordinators of STC, all departments here, associating faculty members, staff, and all participants. Firstly, I would like to wish you all a very warm good afternoon. It is my great pleasure to welcome you all and thank you to all of you for being here with us today. I am very pleased to welcome you to the valedictory ceremony of 5 days short-term course in the hybrid mode on machine learning in healthcare and agriculture, organized by the Department of CSE. It started on 9th May and ended on 13th May. The goal of this STC was to provide an academia and industry level knowledge in the field of machine learning and deep learning, with specifically its application in healthcare and agriculture. I have already summarized the session of every resource person in their session only. So we already have studied and seen what what the things have been taught. So after all the expert lecture, I am certain that the goal has been reached and the participants now have a very good idea about the machine learning and deep learning. I thank all the speakers and the participants for making this STC a successful event. I would like to express my sincere gratitude towards Director Sir, Professor Pradeep Kumar Jain. Director Sir has always been a source of motivation. He never fails to amaze us with his ability to inspire us to challenge ourselves, enabling us to leap forward. Sir, your charismatic energy and devotion to your institute is an inspiration. Thank you, sir, for providing me with such a wonderful opportunity to coordinate this STC. Thank you. So I am coming to now feedback sessions. So you all have attended 5-day STC, and I knew that you have learned a lot. But if any issue or if you, so I am just curious to your experience in this STC. And thank you, participants, for such an overwhelming involvement in this event. I hope this short-term course was worth your time and has provided you all with a great insights and knowledge in the field of machine learning and deep learning. I look forward to your feedback, be it appreciate or criticism. So feel free to express your mind. Please, one by one, online. Online participants, please share your experience about this sort of course.
Sir, good evening, sir.
Yes,
This is
ma'am.
Padma Usha from Crescent College, Tamil Nadu, sir. We thank the coordinators for making us in connection with the IIT and NIT professors in one forum, because we don't get a chance like this. Really, it is a wonderful experience to attend this 5 days short-term course, sir. And I am doing research work in brain tumor detection. So I had a lot of doubts which I couldn't clarify. So, but in this forum, it had a greater experience for me. Most of my doubts had been clarified by the eminent professors. We are expecting this kind of session in the coming years, sir. Thank you.
Thank you so much, ma'am. Definitely, of course, we are going to conduct such kind of event in the near future. Yes. Any other?
Good evening, sir.
Yes, good evening, ma'am.
Sir, this is Rahila from ITM Gorakhpur, and I would like to share my feedback regarding the sessions. All the sessions were very good, and thank you so much for conducting such valuable sessions. And we hope to participate in these types of workshops in future in physical form at IIT Bhagalpur. And the keynote session was especially very knowledgeable, and we thank you sincerely.
Thank you, ma'am. Yes. Please next.
Hello, sir.
Jitendra, good evening.
Dr.
Please.
Shweta Srivastava this side.
Yeah.
Oh,
Yes, ma'am. Yes, ma'am. Please. Yes, ma'am. Your voice is audible. Please, Shweta Srivastava, ma'am.
hello, sir. Dr. Shweta Srivastava this side from Amity University, Noida. The sessions were really invaluable experience. In fact, some of the series have really equipped me with some skills that I really needed, especially today's session by Dr. Deepak. Special thanks to him. Attend such sessions in upcoming future as well. Thank you a lot for arranging this.
Thank you, ma'am. Next, please. Please, next.
Hello, good evening, sir.
Yes, sir.
Good
Yes,
evening,
sir.
sir.
Good evening.
Hello.
Yes, sir. Yes, sir. Please.
Sir, I am Senthil Kumar from EJ Civil Engineering
Audible,
College,
audible. Your voice
Nagapattinam.
is audible. Please.
I'm research domain is image processing. The machine learning, your healthcare and agriculture workshop is very useful for my image processing domain. The supervised learning and machine learning algorithms under filtering methods. So is clarified for my research purpose. Thank you, sir. Thank you for all staff members, doctors.
Thank you, sir. Thank you. Please next. Yeah, next participant.
Hello. Hello.
Yes, yes. Sandeep Modak, sir. Please.
Yes, sir. Good evening, sir. Present there. This side, sir, Dr. Sandeep Modang from Sarlavilla University, Ranchi. Sir, it's give us a pleasure to attend this FDP, this kind of FDP. We are very happy to attend this kind of 5 days FDP. Through this FDP, sir, we got lots of idea about what is machine learning, what is supervised, unsupervised, reinforcement learning, and the best part is that next we are very willing to know about how this can be used in a deep learning process, because deep learning is nowadays very useful for healthcare and as well as agriculture. So looking forward for this, sir, and thank you so much once again for organize this kind of FDP. And we are all I am also congratulate all the organizing committee for organize such type of events. Looking forward, sir. Thank you so much, sir.
Thank you, sir. Thank you. Next, please. Next. Next one.
Good evening, sir.
Good,
Good evening.
Good afternoon to all.
Yes, yes. Good
I am
evening.
Kanjan Bala, Assistant Professor of Government Engineering College, GC Gaya. I am very glad to be participant as well as a resource person of this wonderful events. I would like to extend my gratitude to all the participants, resource persons, coordinators, and organizing committee. Especially thanks to Dr. Dilip sir, who giving me such opportunity to be a part of a short-term programs and some sessions like the Python programming with the various data sets were very informative, and the hope in the future such event will be organized. Thank you so much, sir.
Thank you, ma'am. Thank you. Next, please.
Good evening, sir. Hello.
Good evening, sir.
Yeah, yes, sir. Yes, sir. Please.
Good evening, sir. My name is Chandra Kumar Jadavik. I am pursuing MCA from India Institute of Technology, West Bengal. This short-term course is very helpful for us, and I am sure that we have to very helpful this short-term course in the future. Thank you, sir.
Thank you. Thank you. Next, please.
Good evening, sir. This is Monica from JL Bajaj Institute of Technology, Mathura. Uh, Actually, this session was very fruitful for us, and actually, I never study the machine learning as a subject for BTech, and this is very important for my PhD. So, thank you so much, sir.
Thank you, ma'am. So please next. I'd also call in some offline mode. Please come. Is there Vijit? Yeah, Vijit, please come. You also share your experience. Some feedback should be also from hybrid mode who attended. Please come.
Hello.
Yeah, hello. Yes. Jitin
Uh,
sir.
yes. Dr. Dilip Kumar Chaube sir is a my pleasant moment in a multi-dimension. Though I'm not the participant, I got an opportunity to have a session for 1 hour, and due to my official commitment, though I wish to join all through and go through all sessions, but I missed it. But one or two observations which I would like to infuse with all audience as well as the organizing member. The nascent institution like Triple IT Bhagalpur, as per my memory, 2016 and 17 it has been started, if I am correct. That too in a state like Bihar that needed such a great institution of national importance long back. And you people during last 7 8 years, at least I have been watching it for last 2 3 years since you're joining there. We realize a great service towards the nation in terms of presenting a reservoir of knowledge to different categories of audience ranging from student, researcher, scholar to faculty members in a more viable manner, in a very organized way and effective way. Though I say that woods are lovely, dark and deep, but we have promises to keep, miles to go, miles to go, miles to go before I sleep. Knowledge never end, learning will never end, but the way you people are proceeding with as a responsibility of this country and citizen fellow, I wish and I hope we support too whenever you need. Such organizational diffusion is very important, and I thankful to you people who are doing it with full commitment and zeal. Thank you so much. Keep it up and keep rocking. Thank you.
Thank you, sir. Thank you so much, sir, for such a nice comment to encourage us. And please, next, is there any some more feedback in online mode? Okay, so in offline mode, I will take one to more feedback. Please, Abhijit.
Good evening, sir. Under the esteemed patronage of Director Sir, this short-term course was very helpful, coordinated by Dilip Chaube sir. And this course was not only of theoretical sessions, but also of practical sessions, many hands-on sessions, which was really helpful. In this outcome course, I came to know with very new concepts in various fields, like how can I detect brain tumor using CNN, and how can I use thunderstorm things, how can I detect ECG signals, and how can I use machine learning in the field of agriculture, explained by Sandeep Raj sir, how he used his knowledge about artificial intelligence and machine learning in agriculture. All these things was really helpful. And this course has a significant importance in increasing my knowledge. And this has really beneficial for my MTech degree and further higher studies. Thank you, sir, and all of the coordinators in the report.
Okay, thank you, Abhijit. I will also call one, two girls. Please, Sweta, you come.
Good evening, sir. I Shweta from MTech, Triple T Bhagalpur. The short-term course has been extremely valuable, especially with a theme focused on machine learning in agriculture and healthcare, providing ample knowledge for conducting the research papers and project in the future. The coordinator, Dr. Dilip Chaube sir, has played a significant role in organizing this course, putting the effort to ensure its success. Joining the course offline has proven to be highly beneficial as it facilitated better understanding of the concept. I would like to request that in future courses, the coordinator increase the number of offline seat available, allowing more people to gain knowledge from it. Many thanks to the coordinator for putting in so much effort to make the course successful. Thank you, sir.
Thank you so much. So one more last feedback. Divya, you just also come and share your experience.
Good evening, everyone. I am Divya from Tech. As a participant, I had the opportunity to give feedback. The short-term course organized by the coordinator has provided valuable knowledge which can be useful for the future research papers. The coordinator has put in a lot of efforts to make this course successful, for which I am very thankful. Thank you once again for your hard work, commitment, and professionalism. I look forward to the possibility of attending future course under your coordination. Thank you, sir. Thank you very much.
Thank you so much for such a wonderful feedback from all of you. Thank you so much. Ujjwal sir, please proceed.
So, I would like to request our campus coordinators, sir, to present mementos to the organizing committee members and the expert lecturer talks. Now, Dr. Tejaswini ma'am, organizing committee member. Next, Dr. Gaurav Kumar. Next, Dr. Gaurav Kumar in absence, please give anyone. So, I request to HOD Mechatronics to receive this mementos. Now, I will request our coordinators, Dr. Dilip Kumar Chaubey sir, to give the mementos for organizing committee members, campus coordinator, Dr. Dheeraj Kumar Sinha sir. Now, I will request campus coordinator, Dr. Dheeraj Kumar Sinha sir, for giving memento for the organizing committee, our coordinator, Dr. Dilip Kumar Chaubey sir. Next, I will request again Dr. Dheeraj Kumar Sinha sir for giving memento to co-coordinator Dr. Ravi Shankar Mehta sir. Dr. Ujjwal Vishwas, co-coordinator. Please. Sorry, sir. So next, actually, I'm sorry to say that due to absence of director, sir, I missed this one. So I request our campus coordinator, Dr. Dheeraj Kumar Sinha, to give this memento to any respected HODs of our department or anyone, please, in absence of him. So campus coordinator will give this memento to. So Dilip Chauve, please, Dr. Dilip Kumar Chauve received this in absence of him. Now, Dr. Pradeep Kumar Viswal sir, the campus coordinator, Dr. Dheeraj Kumar Sinha sir, will give this memento to Dr. Pradeep Kumar Viswal sir, organizing committee member. Next, Dr. Om Prakash Singh. Now I will request, thank you, Dr. Dheeraj Kumar Sinha sir. Now I will request our HOD madam to give this expert lecture memento to Dr. Sandeep Ras. Request our HOD madam to give memento to Dr. Chandan Kumar Jha sir for this expert lecture. I also request Madam to give Dr. Dilip Kumar Chaube sir for his expert lectures. Please, Madam. So now moving forward, I will request our respected Assistant Registrar, Mrs. Abhilesha Bharti, to collect a gift from our respected Campus Coordinator, Dr. Dheeraj Kumar Sinha sir. As he is absent, anyone please come forward and take these presentations or gift. Now proceed. I will request to hand over the gifts for the staff members by the coordinator of this short-term course. Please hand over the gifts to the following members: La Pandey, JTS, Ashok Kumar Prasad, JTS, Lakshmi Kumari, JTS, and Bajrangbali Kumar, JT, and Saurabh Kumar, JT, from the Triple IT Bhagalpur. Please hand over this gift to our staff members. Please come forward to collect this gift from our coordinator, Dr. Dilip Kumar Chaube sir. Next, Gaurav Kumar, please come forward to Next, Manojit Thakur, electrician of this IIT Bhagalpur, and Shotto Narayan Kumar, electrician. And also, I request Anjani Kumar for receiving this gift. Now I would like to request our offline participant for their regular attendance and performing well in the STC. I would like to request HOD Madam to hand over this gift to the participant for their outstanding performance and also their attendance. Please, Robi Bhushan Dixit, PhD student. Kollan Mondol, PhD student. Shubharna Roy, PhD student. Abhijit Mishra, MTech student. Sweta Sinha, MTech student. Mithilesh Kumar Mondol, Kapish Thakur, Saurabh Kumar, Dibya Mala, Mayank Pandey, Pushpender Singh, and MD Usman Zafar. Please come forward and take this appreciation gift. So Manjeet Thakur from IIT Bhagalpur, electrician. Now I would like to request our campus coordinator to say some few words towards our participants.
Very good evening to a very good evening to all. First of all, would like to welcome you all on this valedictory function of this short-term workshop. On behalf of Director Sir, I'm very feeling privileged to have you and speak some words on behalf of him. So, as you can see here, you have the workshop started on 9th of this May 2024, and it has taken 5 days to complete this course. I hope everyone has enjoyed the lectures of the industry experts, professionals from the IITs and ITs. You must have heard, must have seen what the area they are working on, and what the role of AI in the area of the healthcare, in the area of the for farmers they are working on. So once again, I would like to congratulate our organizing team, Dr. Dilip Kumar Chaube, and co-coordinators, Dr. Ujjwal Biswas and Dr. Ravi Shankar Mehta. They have done tremendous work to bring all these more than 150 participants, and they have done excellent work
towards conducting such kind of workshop. This kind of workshop should be continued, and we always want to have this kind of workshop in the offline mode also, so that they will have more exposure towards the practical thing. So we have seen we would like to thank the keynote speaker, Kundan Lal sir, and all the experts from the IITs and NITs. They have given so much of time so that the participant can learn that what the area they need to work on. We would also like to thank the HOD madam of CSE who has so much pain and time, and they have done tremendous work in organizing such kind of workshop. So once again, congratulations to all, and would like to see you in future also. Thank you.
Thank you so much, sir, for your valuable words. And now I would request our HOD madam from Department of CSE at IIIT Bhagalpur, Dr. Tejaswini M, to deliver the vote of thanks speech.
So a very good evening to all of you. So the first I would like to thank our Honorable Director Sir, Professor Pradeep Kumar Jain sir, for giving this opportunity to conduct this workshop. So, and I thank guest of honor and keynote speaker, Mr. Kundan Lal, President with the Research Foundation, for providing his valuable time and coming and giving his keynote speech. So I would like to thank our campus coordinator, Dr. Dheeraj Kumar Sinha, our registrar in charge, Sir Dr. Gaurav Kumar, all our department, various department faculty, staffs, volunteers, our network administrator, JTS and JTs. So all they have worked very hard for these 5 days, and I am very thankful for their kind support. And this workshop, so when I heard that the number of participants are 186, so I was very happy. So this workshop is successful because of this large number of active participation of these participants. So I would like to thank them for their patience and active participation. And not last but not the least, wherever our students, there will be success. So every event, whatever we conduct in IIIT Bhagalpur, it is success because of our huge support and kind support, active participations of our students. So the share also goes to, maximum share also goes to our dear students for their presence both in online and offline actively. So, and in futures we will try to conduct even offline courses So we will try to provide our practical workshops also. So thank you for all of you, and have a nice day, and thank you. So yeah, so one more thing. So I would like to thank on behalf of CSE department, Dr. Dilip Kumar Chobe sir, coordinator of this workshop, and the co-coordinator Dr. Ravi Mehta sir and Dr. Ujjwal Biswal sir. So it's a very huge success on behalf of CSE department. So I would like to thank them. Thank you, sir, and in future also we will support you to conduct this kind of workshops. Thank you very much.
Thank you, madam, for your valuable words and encouraging the participants and all the coordinators and co-coordinators. So, I coordinator, sir, Dr. Dilip Kumar Sove will definitely organize such programs, and we will get definitely some information and some new knowledge and technology, and using this technology from various departments and across India. So I feel very proud as a co-coordinator of this session, Dr. Ujjwal Vishal from the Department of Computer Science, IIIT Bhagalpur. Now finally, I will request our co-coordinator, Dr. Kumar Choube sir, for he is announcing the close of the registration with details for the certificates and the session recordings. Thank you to all, and I'm handing over to Sir Dr. Dilip Kumar Sumi.
Yes, so you will get all the recording session by within 1 or 2 days. I will also share materials what I will receive from resource person. But definitely we are going all the recording to all of you, and you are going to get e-certificate soon. We'll try to do a level based within 15 days. You will also definitely get it. Okay, so I am thank you very much to participate in this short-term course. Thank you so much, and I announce to close the valedictory session. Thank you.